Hi, my name is Luesoni Johnson. I am a sophomore at Kingsburg Community College, and the research I did was over the summer, which was at Wagner College on Staten Island. And the lab where I worked at was the zebrafish lab. And in the lab, I was assigned to Dr. Phillip, which was my mentor. And the research was on using zebrafish embryos to see if it would show fetal alcohol syndrome, which is present in humans. So we took three concentrations of alcohol, which was 0.5, 0.05, 0.1%, and the control, which was regular egg water. And the experiment lasted for 14 days, and every day we took pictures and we added the different concentrations of alcohol. And after that, we saw that it did show fetal alcohol syndrome. And fetal alcohol syndrome is present in humans, mainly women who are pregnant. And when the woman who's pregnant, when she consumes the alcohol, the child will be born with microcephaly, which means small head. And we saw the same physical features, which was present in the zebrafish. The farm zebrafish in the different concentrations showed a very small head. Some of them had bent tails, some of them still had their yolk, and also the eyes were more closed in, and everything else was disproportionate to the belly. Now we think that the yolk was still present because there's this enzyme called there's this enzyme called alcohol dehydrogenase, and it's an enzyme that is present in all organisms, even humans. And this enzyme breaks down the alcohol concentration in the body. Now we think that the lowest concentration, which was 0.05%, some of the eggs did not hatch. In the normal developmental stages, the zebrafish egg is supposed to hatch on the third or the fourth day. However, on the seventh day, in the experiment when we took the pictures, the zebrafish did not hatch. And we think that the enzyme, alcohol dehydrogenase, it was inactivated because the concentration was too low, so it did not trigger the enzyme. And also for the highest concentration, which was opposite of what happened to the lowest concentration, which was 0.5%, some of the eggs hatched and some didn't hatch. And we think this is because the enzyme was activated, but the concentration was too high, so it did not trigger the enzyme to function properly. And the middle concentration is 0.1%. All of the eggs hatched. And now we think this is so because the enzyme, it activated and the concentration was suitable for the enzyme to actually function. Then afterwards, when the whole experiment was done, we made a graph and we showed the survival rates of all the zebrafish. And what we noticed was, surprisingly, that the lowest concentration is the 0.05%. All of the eggs died on the 10th day, while a slightly higher concentration, the 0.5% and the 0.1%, they survived longer. And we found this was a bit strange, and my mentor, Dr. Phillip, he told me about hormesis. Now, hormesis is when you have a low dosage and it will show the similar effect as a high dosage. And normally you would see a U-shaped or J-shaped graph, or inverted U-shaped graph, or inverted J-shaped graph. And when we plotted this using the 7th day and the 14th day, we saw it was an inverted U-shaped graph. Now, I was very happy because in the beginning, as I told you, my research was pertaining to fetal alcohol syndrome. And when I saw it was hormesis, it was even more happy because in research, you're always finding new things. And I'm very excited to be here at this conference because even though I found out about hormesis and Dr. Phillip invited me, and we met with Dr. Calabrese, and I'd like to thank him for inviting me to present at the conference. Thank you.